Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is Transform Fixed Length to COBOL COMP-3. Feel free to reach out to me on popular social media channels at Paul Brett Tech. In this practical demonstration, I will design a mapping to transform from fixed length input data to COBOL COMP-3 and validate it back again. We'll start with importing a type tree from a COBOL copybook that includes at least one COMP-3 field. I will then manually build a type tree for fixed length input data. Then I will create a map that reads the fixed length and writes out our COMP-3 data. Finally, I will create a map that validates it back in again. I'm starting this demonstration in the ITX 1010 Design Studio. As you can see, I have an empty project called Fixed to COBOL, and within this project I have already copied in a COBOL copybook ready for the import process. Let's start with that. Let's choose Import COBOL Copybook. We will point to our copybook file. Before we click OK, I just want to show you the content of that. Here's the content of the copybook. It's listing a record layout and 5 fields. The first one is a text field of 5 characters. We then have 3 COMP-3 fields. Finally, a text field of 20 characters. The first of the 3 COMP-3 fields is an integer, and these two represent decimal numbers. On with the importer. I click OK. I click Next. I don't have to change any of these right now. I click Next. I'm going to change the file name to Output. The MTT will be added for me automatically. The type tree has been created. Let's open this now. Here's my row layout, and here are the fields within it. If I double click on the row layout, you will see that we've got the fields in the order that they are listed in the copybook. However, under the fields category, they're not listed in the same order. This is not absolutely necessary, but for aesthetics' sake, I'm going to reorder them into the correct order. You'll also note that there is no file level object showing multiple records. I'm going to add this manually now. This is because my copybook didn't have it. So we have a group level object called File. I'm going to double click that, and within File I'm going to have multiple records. So I'm going to right click, set the range from 0 to S. Within the properties, I'm going to change the format to be explicit. And instead of fixed, it's going to be delimited. And each record is going to be delimited with a new line character. And instead of infix, I'm going to make this postfix. I believe that is my type tree for output ready to go. I'm going to analyze structure and logic. No problems found. Just a simple warning. And I'm going to save that type tree. That's my type tree for output, imported and manually adjusted to suit my needs. Next step is to create a type tree for input. Now this is going to be fairly similar to the output structure. So I'm going to create a new type tree from scratch and bring the two type trees side by side to build it up slowly. My new type tree is called input.mtt. Drag my output type tree tab over to the right of the screen. We can get a split screen and see both items at the same time. Let's start with a category to store my fields. Temporarily, we're going to change the properties of this category to be item, so that each one, as I create it underneath it, will be created as an item, and only once they're all created will I change it back to category. This is a time saver. That's all my fields created. I can now change this object back to category. and we'll go through each field one at a time and make sure the properties are set appropriately. Now, as we know, our input is going to be fixed size, so let's have a look at the size properties for this first object. This item number I'm going to associate with a maximum size of 5 bytes. We're going to look at the pad property, which is currently set to no. We'll change it to yes. And we're going to pad it with spaces to a fixed size, 5 bytes, justified to the right. I think that's everything completed for that particular item. Let's move on to quantity. Okay, this needs to be not text but a number. It defaults to integer, which is fine by me. The maximum size I'm going to make equal to the maximum size of the output side, which I believe is 10. Currently not padded, so we'll change padding to yes. It's padded with zeros to a fixed size, 10 bytes, justified to the right. Perfect. Next up, unit price. Again, this is a number. However, it's not an integer, it is a decimal. Separators I'm going to turn on. I'm going to make them mandatory. And for places, I'm going to say minimum 2, maximum 2. Because this is a currency, there's always going to be 2 decimal places here. Moving on to pad, it's currently no, let's change it to yes. We're padding with zeros to a fixed size. What length to choose? I'm going to go with 15 and also pad to 15. Oops, put the pad in the wrong place. It's already set to 15. Perfect. Okay, so we've got padding with zeros at 215. We're going to repeat that set of properties on total amount. And finally, the description field, which is going to remain as text. Max bytes, I'm going to put 30. Again, padding needs to be changed to yes. Padding with spaces to 30 bytes. I'm going to change the justify again to the right. Okay, I believe that's all of our input type properties created. Next, we need to create a row entry to take these items. Create row. I make it into a group. Double click row. And the components of row need to be these 5 fields in that order. They will default to a 1-to-1 range, so I don't need to set it explicitly. Final thing to do is to create a file level object. Oh, actually, row format needs to be changed to explicit, and we can leave it as fixed. Every single item within it is a fixed size. So now the row is also a fixed size. This should work perfectly. Moving on to the file object. Also going to be a group. Within file we have row, and now we can set the range on this. 0 to infinite rows. I believe that's the structure of our input type tree complete. Let's analyse structure and logic to see if we've made any mistakes. Nope, looks good, so we can save this type tree. Okay, next we want some data. So let's create our map source file. I'm going to call it examples. And within that, a new map, example1. Over on the outline view, we have example 1, currently no cards. Let's create a new output card. The type tree is going to be our input type tree. The object is going to be the file object, and the file I'm going to create is input.txt. I'm going to insert the none rule for the repeating group rows and right click and choose add index to manually add one row. This is to help me create some input data. I've just realised I didn't add any formatting to the file object, so I'm going to go back and do that now. The file object will need some kind of formatting. Currently it's set to sequence implicit. I'm going to change it to explicit, not fixed but delimited. We're going to delimit with new lines, and again we're going to change this from infix to postfix. Okay, back in the map, I'm going to right click the row object and add an index to create a manual row, and I'm going to put in a rule now to manually populate one row of data. So because this is text, I'm going to put it in as a number 1 in quotes. Quantity I'm going to put in as 10. Unit price I'm going to put in as 9.99, which equals a total amount of 99.90. And for the description I'm going to call these widgets. So if I save, build and run this map, a file is created called input.txt, and if we open that you will see the fixed length structure that I've been creating. The first 5 characters are the item number, which is justified to the right and is a 1. The next 10 characters is the quantity and is a 10, padded with zeros, justified to the right. Then we get our unit price at $9.99, then our total price at $99.90, and finally our description, widgets. Now that we have this row in the file, we can quickly cut and paste to create additional rows without having to create rules and type in all those rules again. So I'm going to create 3 rows of data. Bit of a pasting error there. I'm going to change the item numbers to 1, 2, 3. And instead of 10 of this object, I'm going to have 100. Instead of 9.99, let's make them 1.99. If my math is correct, the total value should be 199 exactly. Let's make the description different. Then my word that I've used there, what's its, is 1 character too long, so I'm going to have to remove one of the padding characters manually. Moving on to row 3, instead of 100, let's have 1000. Let's make the price 4 exactly. Gives me 4,000 for a total, and let's come up with a new name. Again, I need to adjust my padding characters to keep the line length correct. Okay, so there's my updated input file. Let's move on to the next map. The next map will use this card as input. So I right click it, I choose copy, I create a new map name, example 2, I say I want this copied as an input and we'll call it in1. So there's the start of my new map, example 2, it's on the input side, it's reading this file. In theory this Typetree should read this file no problem. Run the map, it validates that input perfectly. Now I can create my real output card, which is sending it to the file format defined by the import that I did from the copybook. We'll call the card out1. The type tree we're using this time is the real output.mtt. The object we're choosing is file, and the file we're going to write to is output.txt. Okay, we've got repeating objects on input, repeating objects on output. We're going to need a functional map. functional map has been defined but not yet created. If I right click and choose functional map wizard, that does all the hard work for me. My functional map is created, and within that I can map manually. I could use the auto mapper, but for this few fields it's just not worth it. Okay, back to the top level, save, build and run. We've got a little warning there saying that the size of the input item is greater than the output item. We'll ignore that for now. A new file has been created, output.txt, which we shall open. And if I drag that down and do a split window here, we can see our input and our output. You can plainly see that there is some binary data in this middle section here. This is the packed decimal that is needed for COBOL Copybook format on the mainframe. Specifically, it meets the copybook definition that we imported earlier. Now there's one more map I want to create, and it's a map that will validate this output we've created. In theory, this Typetree should be able to read this output, and I know for a fact that it won't because there's a bit of a bug on the importer for this version of ITX. So let me show you that now. I'm going to take the output card, and I'm going to copy that to another map, example 3, as input. I'll call it in1. So example 3 has been created now. This is the map. The input card is going to be reading the file that we just created, and if I build and run this map, it is going to complain input valid but unknown data found. Now why is this? Well, let's just quickly go back to our Typetree for a moment and bring up the properties of the first field, item number. Now if you have a quick look, you will note that there is no maximum bytes set for this field, and it is not padded. Therefore, the validator has absolutely no way of knowing where the first field ends, and if you turn on the tracing for this map, it will read too many bytes from the binary portion of the next field, thinking that it's trying to still get the number. Now this is a problem with the importer. The importer should have read the copybook file. It should have read pick x5 and created a field that was 5 bytes padded to 5 bytes. If you import the same copybook using a later version of ITX, it does create it correctly. But for now, let's just update it manually. So if I put in here 5 bytes, padded yes, padded with spaces to fixed size 5 bytes, justified to the left, that's fine. It doesn't matter whether it's left or right for me. From the tree menu, choose Analyze Structure and Logic, and then save that file, update the maps. I'm going to need to run example 2 again to recreate that output. Build, run. Turns out there's a second mistake. The record level object is not set as explicit fixed. So let's make that change manually as well. Explicit fixed. Tree, analyze structure and logic again. Save the Typetree. Build and run the map. And as you can see, the output changed that time. Field 1 is now padded, and if we go to our example 3 where we're validating that output, you can see the map has completed successfully. This is valid as per the definition. That copybook should have created the right definition the first time, and what I will say is that if I was using ITX 10.1.2, then that's exactly what it would have done. It would have created that first field with a padding of 5 bytes, and it would have created the row level object as explicit fixed format. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Perhaps leave me a comment. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.